Let's put this all together. We'll use the given graphs of a rational function to find the following. So what we're going to do is read these graphs. Let's write the equation of the vertical asymptotes. Let me grab my pen here. So as I look at example A, the vertical red dashed line is at x equals 1. So the vertical asymptote, it's an equation of a line, we would say is x equals 1. There's also a horizontal dashed line at y equals -4. So y equals -4. That's our horizontal asymptote. So when you're asked for asymptotes, they're equations. Vertical asymptotes are always x equals, and horizontal asymptotes are always y equals. Is there an oblique asymptote? No, there is none. Are there any holes? Yes, I see a hole right here. So we represent a hole with coordinates. So it's -1, -1. Oh, excuse me, the y-axis is counting by 2. So it's -1, -2. So there's a hole at -1, -2. There are intercepts. There's only one intercept because it happens to be the y-intercept and the x-intercept, the origin. So there's one intercept, and it happens to be the origin. Now, reading the domain, as I read from left to right, I have a couple of excluded values. I cannot equal the value that documents the whole, and I cannot equal the value of x that is the vertical asymptote. So I have two excluded values here, -1 and +1. So writing that in interval notation would be -infinity to -1. We have to jump over -1 using parentheses on both ends here, and then we also have to jump over +1. So in interval notation, we'll have three intervals joined by the union symbols, and we exclude -1 and +1 by using parentheses. Now reading the range, that means we read from bottom to top, and we only have one excluded value there as a horizontal asymptote and one excluded value there as a whole. So in the range, we have to exclude -4 because that's a horizontal asymptote, and we have to exclude the value -2 because it doesn't exist. So from -infinity to -4, jump over -4, also jump over -2 because that's a value of the function that doesn't exist because of the whole. So the range also has three intervals joined by the union symbol. Now let's read and write the behavior near the vertical asymptote. As x goes to or approaches 1 from the left, what does f of x do? Well, as f approaches +1 from the left, y is going to infinity, positive. As x approaches 1 from the right, f of x is going to -infinity. So from the right, see here as I trace and come to x equals 1, from numbers bigger than 1, I'm shooting down to -infinity. And the end behavior, well, we have a horizontal asymptote, so we know both end behaviors, both the left and the right end behavior, will approach that value. And as you read the graph, you see that the function approaches the horizontal line -4. So as x approaches -infinity, f of x approaches -4. And as x approaches +infinity, f of x approaches -4.